as I'm recording. So, hope you all are still doing well. I'm trying to get ahead of my recordings. Okay, go away, little box. And so, happy Friday. We're in the same clothes as yesterday because it's still the same day for me. Whatever. No big deal. Okay. We're going to do the very last lesson. It's going to be interesting because you do need your graphing calculator. Yeah, so if you don't have your graphing calculator, you should pause the video right now, go grab your graphing calculator. Go grab your graphing calculator right now. And because we're going to be doing some curve fitting using your graphing calculator. Yeah? All right. Go grab it. All right, so with statistical applications, exact relationships may not exist. Often an average relationship is used. And so regression analysis is what we call a collection of methods by which estimates are made between two variables. Correlation analysis tells the degree to which the variables are related. And then a scatter plot is a good tool for recognizing and analyzing relationships. So we're going to be doing all of those. We're going to be doing regression analysis, correlation analysis, and we're going to be making some scatter plots, all using our graphing calculators. So you've got the independent variable is always on the horizontal axis. Dependent variable is on the y-axis or vertical axis. So your dependent variable will be the prediction to be made, and the independent variable is your basis for the prediction. Independent versus dependent variables. Not always, when we're talking about correlation, there's not always a independent and a dependent. So sometimes, these graphs could be plotted either way. But if we can say the one depends on the other, then obviously we'll use horizontal axis for our independent and then the vertical axis for our dependent. All right, so obviously pause this if you have not finished writing it down, and I'm going to go to the next slide. So the first example says a college admissions committee wishes to predict students' first year math averages from their math SAT scores. And here was the data plotted, where they put SAT scores on the horizontal axis, and they put the grades in their first year math classes from college on the y-axis, right? So they're talking about, let's see if SAT scores can predict how a student will do in their first year of math class. So here's that's that scatter plot. Yeah, and notice that the points are not on a clear straight line, right? That's normal, that's life. Not everybody fits on the same single line. We all know this, right? But the plot still tells us some stuff. And what it tells us is, in general, higher SAT scores corresponded to higher grades. And you can see that along that scatter plot, right? That they're generally, it's going up, right? That as you move over here along the horizontal axis, the higher those go, it seems to be that the higher the grade is. So in general, not always, right? You've got, in general, the higher SAT score corresponds to a higher grade. It definitely looks like a positive relationship, meaning as you go right, you're going up, right? Higher, higher, so a positive relationship. And it's not all curvy, right? It kind of looks like it's going in a straight line, or it's a direct relationship. So our graphing calculator can plot these scatter plots. We can plot just these little dots. And then remember to identify which variable is the independent and which one is the dependent. And then once we have a scatter plot, then we will identify the line or curve that best fits those points. All right. So some examples, and you're going to fill in the names of these guys. So this first one is a direct linear. There's a box for you to fill this. Direct linear, right? Oops, whoa. Let me go back, hit a bunch of buttons. Did not mean to do that. Sorry. There we go. Okay, direct linear. Like, they're not all landing on that line, but they're basically all kind of surrounding the line. Direct linear. And as x is increasing, y is increasing. Inverse linear means that as x increases, y is decreasing. So notice the slope is negative. That's an inverse. And then linear, because they're pretty much on this straight line. No, they're not exact, but you can kind of draw a straight line going through it. Curvilinear would be any of them that curvy, yeah. We could have a direct curvilinear where it's curvy, right? In general, they look like it's curving and not just a straight line. But it's also direct, meaning as x is increasing, y is increasing. We have inverse curvilinear, where again, they're not so much in a straight line, but they're kind of curving. But inverse meaning as x is increasing, y is decreasing. And then you got all these randos, right? There's absolutely no relationship whatsoever here. They're just completely all rando. Okay, so those are some examples. Statisticians use the method of least squares to obtain a linear regression equation. What they do is they'll use, you're used to seeing y equals mx plus b. Your graphing calculator is going to do it this way, where they're going to give the y-intercept here and then the slope as b. So keep that in mind. It's not y equals mx plus b. It's y equals a plus bx. And we gave you this little picture. Good. So it turns out that they find this this line, this linear regression, by finding the change in the y values between the actual point and this line of regression. And what it turns out is that all of the sum of all of these delta y's, or change in y's, is 0. And the sum of the squares of the delta y's, they want that as small as possible. And so that's how they end up getting this linear regression line. And so how you're going to be, we're going to be plotting stuff, but we want to turn our diagnostics on our calculator so that it gives us some information. So on your graphing calculator, you are going to hit the second button and then the 0 to bring up the catalog. So second and then 0, and it brings up the catalog of, this is every single program or function that exists on your calculator. I shouldn't say program, but any like function or whatever. And then, so you bring up the catalog. You want to scroll down to diagnostics on. So the list is in alphabetical order, starting with A's. If you notice, where's the D on here in green? Okay. If you notice on the X -1 button right there in green, you'll see a D right above it. This is just a shortcut so that you don't have to scroll all the way down to the D's. If you hit that X -1 button, it'll bring you all the way to the D's, just a quick shortcut. And then you'll still need to scroll down to diagnostics on, diagnostic on, and make sure the little arrow is pointed to that. I don't know how close I have to get to show you. Hopefully that's a good one. And then you'll hit enter for diagnostic on, and your screen should look like that. Diagnostic on, and then hit enter again. And so we've turned on the diagnostics, and that will give us some extra information that we're going to be looking for when we do these scatter plots. All right, so again, hit second, 0, scroll down to the diagnostic on. You could just use that arrow to go all the way to the D's, but the shortcut is to just hit that, find the green D button on your calculator and hit that button, and it'll bring you to the D's faster, and you don't have to scroll through so many. All right, so you want to make sure your diagnostics are on. All right, let's look at this first example. A runner's stride rate is related to his or her speed. Stride rate is like how many steps per second, and then the speed is in feet per second, right? So we're going to plot this using a scatter plot. So the first, and we're going to do it on our graphing calculator. So the first thing you want to do is hit stat, which is the button right next to the arrows. There is a stat button right next to the arrows right here. It's underneath the delete button, so you'll hit stat and then edit, so just hit enter. All right, so you've got two columns. You should have L1 on the first column and L2. For some reason, my calculator was already under L2, so I'm going to arrow over to L1. And under L1, we're going to put in our independent variable. So for this one, we're going to choose speed is our independent variable. So you're going to enter in all of those values under L1. So 15.86. So enter them and hitting enter in between the numbers. So 15.86, enter. 16.88, enter. 17.5, enter. 18.62, enter. 19.97, enter. 21.06, enter. And 22.11, enter. Hopefully that's close enough and zoomed in and clear and not blurry, hopefully. So you put all those in for the independent variable. Then you'll arrow to the right and put in the stride rate for, we're saying that's the dependent variable under L2, right? Make sure that the 3.05 is matched up with the 15.86. Hit enter in between 3.12, 3.17. Make sure your points are correct, like you're entering. You don't hit a wrong button. 3.25, enter. 3.36, enter. 3.46, enter. And 3.55, enter. So that's what I've got right now. And hopefully that's showing up for you nice and clear. And I can't see what you're seeing, so I don't know if it is or not. But okay. So you match up. Make sure each of the points are, you've got an L1 value and an L2 value right next to each other. Okay, so now we've got those entered in. Now I'm going to hit second Y equals to bring up the stat plot menu. And what you want to make sure is under this first one, right now my plot one says off. We want to turn it on. We want to turn on the stat plot. So I'm going to hit enter. And I want on. So I'm going to hit enter so that it's on. You want the very first little scatter plot thing to be selected. You want to make sure under X list it says L1 and Y list it says L2. And then mark, I have the little square box. And then my color is blue. That's just what color it comes out. It doesn't matter what you choose. All right, then we want to make sure that in our window, that we have a nice window, right? So I look at these values and I'm like, okay, the smallest speed is 15.86. My largest speed is 22.11. And then the stride rate, smallest, okay, they're all within the threes, right? So I'm going to hit window, which is second button over here right next to the Y equals. I'm going to hit window. And then just change these values. You definitely want to be past 22.11 on your X's. So I still left 0, and then I put 25 for my X max. X scale, I put 5. That's just how far apart the tick marks are. And since I'm going from 0 to 25, maybe 5 is a good, I don't want to see too many little tick marks. For Y min, they're all positive values. So how about, and they're all from 3 to 4. So I'll just go 0 to 4 and with an X scale of 1. Everything else I'm just going to leave. And then hit that graph button. And I got that, which I did. So there's my scatter plot. Yeah. Beautiful, right? Okay, that looks like a line to me. I don't know about you, but that definitely, it looks like I could draw a straight line through that. I mean, they're not perfect. They may not all land exactly on a line, but that looks pretty darn close. Yeah, isn't it? Like a pretty straight line. All right, so because it looks like a line, I'm going to choose to do a linear regression on my graphing calculator. So we're going to do a linear regression, and oh good, it's on all those directions were on your paper. Yay. Okay, so to do the linear regression, we're going to hit stat, which is again that button right next to the arrows. Stat. This time you don't want edit, you want to arrow over to the calc menu. So arrow to the right, and then I want number 8, the lin reg. So with a plus bx, all you got to do is hit the number 8. You don't have to arrow down and then hit enter. If you just hit 8, boom. All right, and then you want to make sure that under X list you've got L1, and under Y list you've got L2, and just arrow, so you can just go enter, enter. Forget, are we having you store it? We're not having you store it. Okay. If you stored it, you could store the regression equation, and then that makes it where it could graph the actual line going through the points. Apparently, we're not having you do it for this problem. So you just hit enter until you get to calculate, arrow down to calculate, and then hit enter. And you should get these values. My calculator matches what I have on my screen right now. You get this linear regression, right, where here's the form that you have to write the equation in, y equals a plus bx, where a is 1.766, blah, 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 and your b is the 0.0802, blah, blah, blah. And so going to 3 decimal places, I would round to this spot here. So the 0 says keep it as a 6, and then 3 decimal places would be right here. The 2 says keep that 0 alone. And so that is your regression equation. This would be the line that's the best fit line that would fit in between all of those scatter plots. All right, what is R? What is that crap? That's how, if you did not turn your diagnostics on, this will not show up. So hopefully you followed my directions on turning the diagnostics on right from the beginning. Yeah, and R is what we call the correlation coefficient. And what it does is it tells us how good of a fit our regression model is. So it tells us how good that line fits. The closer it is to 1 for a direct linear, or -1 if it's going down, for the better our model fits the data. So to have an R of 0.9989, I mean, that's a really, really good fit. So here's an example. Here's some examples of scatter plots of this one. I mean, look at every single one of those guys fits directly. I could draw a straight line going through these guys exactly. That's an R equals +1. R equals -1 would be a negative relationship, but if it's a perfect one, then they would fit. They have the exact same slope, right, going down. And then R equals 0, if there's no correlation, they're all going to be scattered like that. So on your notes, we have you fill in the R equals 0, R equals -1, and the R equals +1 on those notes. By the way, let me go back. Another option, instead of changing, go back to this previous slide. You know how I had you hit the window and I had you put these things in, right? Totally works, right? But I didn't have to do from 0. I mean, the very smallest value was 15, right? And the biggest was 22. So I could have went, 15 to 25, right? And it just would have shown me a smaller window. Same thing with the Y's. I could have done not from 0 to 4, but I could have went from 3 to 4 and done a smaller scale. The other thing I could have done is if I hit zoom and then 9, it says zoom stat, that really zooms in to just that window. So if you're curious, like, how the heck did I come up with those window values and what did I do to get those? I was looking at the numbers and just making sure that they all fit in there. But you also could do zoom stat, and it zooms in even further, and you can still see, it's a pretty good um, correlation there. Okay, so just another option if figuring out what values to put under the window was like, what the heck would she do? You can always do that instead. All right, okay, so here's these scatter plots and correlation coefficients, right? How good of a correlation it is. How well are they related? All right, so let's match the scatter diagrams with the correlation coefficients. So this guy, definitely increasing, so it won't be these two, right? So we're going to match up each of these four. Well, obviously we're not going to use one of them because we only have 3 graphs. So for each of these 3 graphs, I'm going to choose which one do I think it fits, right? So it's a positive relationship, so your correlation coefficient will definitely be positive. And do we think that it's a 0.3 or a 0.9, right? And whoops, didn't mean to do that. And I would say it's a 0.9. It's a pretty close. It's not exact by any means. There's some wiggle room around there, right? But it's pretty close. Now, it's a rising line, so positive, and our only choices are 0.9 or 0.3. Well, 0.3 would be more scattered about, so. And the points fit fairly well. For the second one, it's negative, so I'm definitely not using these guys, right? And so it's between negative 0.4 or negative 0.75. They're kind of scattered, so I would go with 0.4, yeah? And it's a falling line, so that's where it's negative. The points, it fits the points, but not super close. And then the last one is a positive, barely, right? They're pretty scattered, but it's definitely not decreasing. It's definitely still increasing, but they're not very close, and so that's where I would go with the 0.3. So a straight line is not always the best way to describe a relationship. A lot of times we do find a linear regression and stuff, a linear relationship, but not always. The relationship may be described as curvilinear, which we gave you those examples in the beginning of this lesson. You could have an exponential, and your calculator will do that. It's called expreg, and that's if your x would be up there in the exponent. So if you get an exponential, right, then you'll use that. You could have logarithmic. That's if they kind of curve this way. So here, let me, an exponential. I don't know why it's not letting me change. There we go. Okay. Exponential. An exponential would increase like that. A logarithmic would increase like that. And there's a button on your calculator for that. Reg, right? Logarithmic. And then there's also a power. Like if it looks like if it was a x squared, right? They would look like a parabola. If it looks like a cubic, then it would look like that. And so those are the other types that in your calculator has all of those also. So it's important to do the scatter plot first and see what the basic shape kind of looks like to you, and then choose which regression that you'll use. And all of these can be found in the Stat Calc menu. All right, so let's do an example like that. An accountant presents the data in the table about a company's profits in thousands of dollars for 7 years after a management reorganization. So all of these are not $150, but in thousands. Yeah, so that's their profits over the years. And so let's do a scatter plot, and you'll hit Stat, Edit, and then Enter. the year in L1 and the profits in L2. So stat, edit. You can type over, because we already put things in L1 and L2. You can type over if you want, or if you go to the column you need to, arrow up so that L1 is highlighted, and then push clear, and then arrow back down. I have cleared out that entire column for L1. Do the same thing for L2. I'll arrow to the right, arrow up, I'll hit clear. It doesn't do it until you arrow down, and then it has cleared out both of my columns. So that's the quick way. You can type over, but so I'm going to hit under L1, 1, 2, 3, 4, 5, 6, and 7. Under L2, 150, enter. 210, enter. 348, enter. 490, enter. 660, 872, and 1400. Okay, so for each of them, I've got all the values. Make sure no typos. And you need, if you do something and it says, dimension error or something like that, that means you have an extra L1 or L2 in there or something. Or maybe you don't have enough. You don't have a value matching for each of them. All right, so I've got those guys entered. I'm going to hit window and change my window from my X values are from 1 to 7, so I'll go 0 to 8 with an X scale of 1 in between. And then I'm going from 150 to 1400. So how about if we just go on the Y's, 0 to 1400. But then my X scale, if you leave it as 1, it'll put 1400 little tick marks. So how about if we go by 100? Again, you also could have chosen zoom stat for that, and it should also fit perfectly nice. And I'll hit graph. And that's what mine looks like. Oh, there you go, perfect. But with the window I chose, that's what I got. But if I would have done zoom stat. Zoom stat, it's pretty close. It zooms in a little bit better, a little bit more, and make sure that last little dot for 1400 is a full rectangle or square, I should say. But anyway, regardless, it still takes on the same kind of shape. And you'll notice, like, if you try to do a straight line, this guy right here is definitely kind of curving up, right? So do you see how it's definitely looking curvy to me? And so, to me, it looks exponential. So I'm going to use an exponential regression. So how you do that is you will hit stat, which is that button next to the arrows, calc, so arrow to the right, and then 0, which you can scroll all the way down. After 9, we'll hit you'll get 0, or you can just, I'm telling you, it's exponential regression, so 0. And then you want to make sure L1 is chosen, L2 is chosen. We still didn't store the regression line, so whatever, calculate. And when you calculate it, I got an A is 107.208, and I got a B of 1.43, and it gives you the form of how you write your answer. The regression equation is y equals A times B to the X. So see how I wrote it? Y equals, my A was 1.07.28. I rounded to 3 decimal places. My B was 1.439 because I rounded up that 8, and then to the power of X. So that's like a times right there. So there is your regression equation. Wonderful. What was our correlation? Our correlation was 0.996, so not bad. And then we're going to use this model to predict the profit for year 8. And for year 8, I would just plug in an 8 into this X. So 107.28 times 1.439 to the power of 8, which is 1971.1. Yeah, but what is the profit? Remember, they told us in thousands of dollars, so it's not $1,900. right? It's 1,971,000 approximately. Um, on the homework, maybe they have you figure out what the picture should look like. I know on the test we tell you it's a straight up, like we will say to you, hey, find the linear regression or find the exponential regression line or equation. So you don't have to guess, like in case if you thought that maybe this looked like a straight line, there's not going to be any guessing when it comes to testing you on this stuff. So there we go. Okay, your homework is this, and you just use your graphing calculator for the scatter plots, but then just make a little sketch of what your calculator gives. Oh, that's a cute little name. Scatter plot. Cute. Okay, so there you go. Yes. Um, escape. Nope, I don't want to. Discard. All right. So, stop. Welcome to my world right now where this is lovely. Stop presenting. There we go. Hi again. Okay. I hope you all are doing well. Happy Friday. Have a good weekend. And stay healthy. Stay away from everybody. Talk to your friends on FaceTime or whatever you do to talk to them. Yeah. But lovely social distancing. We will get through this together, right? Of course. It's all going to be good. It's lovely. All right. Have a good one. See you guys tomorrow. Or no, today's Friday, so I'll see you on Monday.